Hey everyone, Adam again. Welcome back for the Lab 4 hardware video. In this lab, it's actually very simple. So all we're going to do is verify all we've done in simulation. So we're going to actually run the amplifier from simulation like we've done before. You can see here I have it set up. So go ahead and set that up. And then you're going to look at about 20 points. So you're going to take points between 100 hertz right here and about 10 megahertz. So 10 megahertz ends up around right here. So I said take at least 20 points between those two and put those in a table. So you're going to put those in a table of frequency versus gain. Okay? So at each point, take the gain, and then you're going to go ahead and also do the same thing in your hardware setup. So make sure you're signing into your science station. Go ahead and actually go into apps. So if it's not open, you can click down here on the bottom right. You'll find apps. So go into Bode plot. Alright. Then you can set it up with a 250 millivolt amplitude. That's fine. And set it to stop at 10 megahertz, right? We want to take points between 100 hertz and 10 megahertz. So let's go ahead and run that. So we can see there's some weird stuff at the start, right? Just like we saw in our other amplifier. So if we go back to the simulation here, we'll see that if I actually decrease this to 0 hertz or close to it, we can see that we have some weird non-linear portion that actually is before our cutoff frequency. And that's just due to the capacitors in the circuit. We can ignore this for all intents and purposes. So let's just start at around 50 hertz. That gives us a nice linear portion followed by a non-linear region. Alright. So let's go ahead and look here at what the points we have to start at. So it looks like we have to start at around 5K. 5K, we'll have a nice linear region. Alright. So I was wrong when I said that originally. I'm going to get you to take points between 5 kilohertz and 10 megahertz. So, as you've seen, me going through the pain for you. So again, we're going to do the same thing on this plot. We're going to look at the actual index down here in the middle. We're going to scroll through it and we're going to find about 20 different frequency points, okay? We're going to want to take more frequency points when we get to the quarter frequencies. And I find the best way to just go through this table is to just use your markers and place them on different data measurement points. So as long as you do that, you'll see where your marker is. It'll tell you the frequency and the gain at that point. So make sure you're taking 20 points in between about 5 kilohertz and 10 megahertz so you can get a nice plot. And then once you're done that, I'll get you to go over to See You Learn, and there you'll find a file that I've created for you. I don't have it there yet, but it's called ELEC 2507 lab4 bodeplots.m. And you'll be able to open that up in whatever you like in MATLAB, or if you just like using Notepad++ like I do. You can put in all your frequency measurements there. You can put in all your magnitude measurements there. And then you can put in all your frequency measurements from multisim as well. So I'm going to add another column here. It's called frequency multisim. So that category will allow you to just plot the magnitude of multisim L, and the frequency of L. So you'll have two different plots on the same plot in different subplots. One will be the frequency from your oscilloscope, and the other will be the frequency and magnitude from your multisim files. And then you can go ahead and plot that in MATLAB, and then export that for your report, and you should be good to go for this portion. Make sure you're comparing and contrasting the 3 dB cutoff frequency of both the filters. So in one of the amplifiers you have a certain 3 dB cutoff frequency, and the other amplifier it's slightly different. You're going to note why that might be, maybe due to operating point, the capacitors that are used. Just to give you an example, and the passband gain of both the amplifiers. So you're going to go ahead and look at the passband. The passband is this linear region up here, and you're going to look at the average gain during that section. So during that section it looks like it's around negative 1.39. So we can go with that, and if you go back to your multisim files, we can see that in the passband we're at around negative 1.349. So we're very close to what we're actually doing in hardware and simulation. Alright, so I hope you guys enjoy the videos, and we'll see you again next time for Lab 5. Bye bye.